Hello everyone, welcome back to my YouTube channel with another video from Google Earth Engine tutorial. I'm here to show you how to estimate soil salinization based on machine learning algorithms in Google Earth Engine. If you like these types of video, please like the video and also subscribe to my channel. Okay, let's start. I'm gonna give you a brief information regarding what I'm going to do here. Here I'm gonna first estimate soil salinization based on soil salinity index. This is very important when we don't have a lot of training data. Then I'm gonna create some training data from estimated soil salinization based on soil salinity index. Then from these training data, I'm going to use for training my machine learning model. Okay, very good. We can start. In the first step, I have to define an study area. This is my study area since I'm sure that there are some salinization here. As you can see, it's added successfully to my screen. Right now, I need to put my study area in the middle of my screen and also add it as a layer. For this, I'm using map.centerObject and the name of my study area. The same thing for layer, map a layer. Very good. Right now I can save and run the code. Soil salinity estimation using machine learning. It's gonna take a while to be saved. Yeah, it's saved successfully. Right now I run the code and until now it's okay. In the first step, I need to call my Sentinel-2 data. For this, I'm using var and give it a name, Sentinel-2. For collection, I'm using image collection. In Google Earth Engine, the time you are looking for satellite data, you can come to search, type the name of the data that you are interested in using. Here we can see two different level of Sentinel-2 data. I'm gonna use level A since some atmospheric correction has been done on this data. And also we can see here a brief description regarding this data, the bands that, and also their spatial resolution, and the other information that you can find here. In order to call, I'm gonna use its ID. In the next line, I need to define my study area that I'm going to do collection for that one. Filter bound is a good option for this purpose. I have to paste the name of my study area here, or I can type it. In the next line, I'm using filter date in order to define a specific date for soil salinization estimation, soil salinity estimation. Depends on your purpose, you can choose specific date for this one. Okay, very good. Right now, I'm gonna use median in order to use the mean of this collection, since maybe we have more than Sentinel-1 data during the specific date for this. I applied median here, and for the last things, I'm using clip for limit the collection into my study area. Right now I can print the data that I've collected. Here I need to put the name of collection, and that's it. Okay, now I'm running the code, and as you can see here, it's uploaded successfully. As I said before, I'm gonna use a soil salinity index in order to estimate soil salinization first. For this, I will use this one, soil salinity index 2, that its formula it's here. You can see here, it's a relationship between band 2, 4, and also 3. By using this soil salinity index, that its band 2 means blue, 3 means green, and band 4 means red bands. You can find information regarding this index on the internet. Let's apply. For this, I need to select first the specified bands, for example, band blue. I'm saying that from my collection, select band 2. In order to check which bands blue belongs to blue, you can come to the product. From bands, you can see here band 2 represent blue, band 3 represent green, and so on. I will rename it as blue. I have to do the same thing for the other two bands. For this, I copy this part, select paste here, and modify its various parts, such as this one is green, the band is band 3, and so this one is green. For the final band, we have this procedure. This time, band 4. Okay, very good. Now everything is ready for applying soil salinity index. In order to apply, I will use the abbreviation of SSI. Need to upload collection. From collection, I'm gonna define an expression and write my formula here. As I said before, it's a relationship between band 2 multiply band 4 divided into band 3. Band 2 multiply band 4 divided band 3 and bracket. Okay, now it's okay. After applying formula, I need to define different parts of this equation. For example, band 2 means what, band 3 means what, band 4 means what. For this, I can come here, say that band 2 equals blue, as defined here. The same thing for the other bands too. Okay. Until now we don't have any problem. Then we can go to the next step and rename estimated result as SSI. This is my preferred name. You can choose the other if you are interested. Right now I need to add it as a layer, and if I copy and paste its name, I have to save the code, run that one, wait until it's successfully applied. From setting, we can add some stretch for better visualization. Deactivate this one. As you can see, the applied soil salinity estimation index here. Right now, as I said before, for machine learning algorithm, I'm gonna define some sample training data from this estimated soil salinization. For this one, in order to better visualize what I'm gonna do, from setting, I'm gonna give them or classify them in 5 classes using palette and this plus. Say that this is a first class. This means very low salinization. The next one, low salinization. This one, moderate salinization. This one, high salinization, and also the final one, very high salinization. By applying, I can see my classification here. This is a very good method when you don't have any sample data prepared from ground control points, but you can easily do this on Google Earth Engine without any problem. Right now, I will go further. I need to define some training data. For this, I'm gonna come here from new layer. Okay, I create one from setting. I will go here from import as feature collection. This part means feature collection. And name to this collection, I'm gonna give it very low. From property, I have to give it a property. I'm gonna give it a soil salinity, and a value that I need to put. For example, 0 is okay, and also a color. Very good. Right now, I can go. As you can see, my cursor is different. It's ready for collecting some sample data. I'm gonna start for this with this part. Okay. Sorry, I used polygon. I need to do it again because I'm gonna collect some sample points from my study area. Again, from geometry to very low. And the color. As I said before, in order to collect some data, I'm gonna use marker and throughout my study area, I have to do this in an equal way. I start, as you can see here, the number of points that I'm collecting. Try to do this as precise as. I'm gonna collect 15 points for each class. We know that increasing number of training data increase the accuracy of our results. Let's do it 20. Okay. We collected sample data for class 1. Right now, I have to do the same procedure for second class. New layer, low, I assume that you learn how to do this. Then I'm gonna go a little faster. By using zoom in and zoom out, you can do it very precisely. And 20 points. We finished the same procedure for this class. I will go to the next. This is value should be 2 and the color. Now it's ready for Okay, we are going to do the same thing for next class, like soil salinization. And the final class, this time very high. Okay, very good. We collected all sample points. As you can see here, all of them added to the script. Right now, we are ready for our machine learning application. In order to do this, first I have to merge all these collected sample points. For this, I'm using training data name and say I'm gonna start from the first class. The name of first class is very low. Try to do this precisely, very low. Then from merge, I'm gonna do this. I'm saying that merge very low with low, merge again, with moderate, merge again with high, and finally merge again with very high. Okay, I can go to the next step. Here I have to input, or let's say define, all the bands from my collection that I'm interested in using in my training. For this, bands, I'm saying from my collection, to choose band 2, band 3, and 4 as the red band, band 8, band 11, and also band 12. Very good. Until now it's okay. We have both bands, Sentinel-2 bands, and also we have training data. Right now I have to define different parts of this in order to combine these two options for training. For this, I'm using training name, and I'm saying from my selection that it's here. Select bands that I define it here, and also from sample regions. Call the collection. This means that I'm using these training data that I defined before and also merge them. Properties. If you remember, during the sample collection, I used properties SS. I will show you right now. Go back here. For example, this is the properties. And for the final one, I need to define the scale. It's gonna be 10 meters. Okay. Very good. This is of course for bands 2, 3, 4, and also 8, these 10 meters. Because they're mostly included in our training, I'm choosing 10 meters special resolution. In the next step, I have to define my classifier. As I said before, I'm going to use machine learning algorithms for soil salinity classification for this. And say classifier. For calling classifier, classifier is a good thing. And from classifier, I need to choose the one that I'm interested in using. If you see here, we have different types of classifier like decision tree ensemble, super vector machine, and also minimum distance, and so on. Depends on your usage. You can choose one of them for your process. Here, I'm gonna use support vector machine as one of the well-known machine learning algorithms. Here, again, I'm saying that with this classifier, train, and I have to define different parts. For example, what features are gonna be inside my training, and say from training, as I define it here, it's gonna be my bands and also training data. And also the class property I have to define here. This one is the one that I used before. And for the final things, I'm saying that my input properties would be my bands. Very good. Right now I defined different parts of separative emission algorithm that I'm going to use for soil salinity classification. In the next step, I have to say classify it. From classified, I'm saying that from my collection that I used here, Sentinel-2 collection, select the bands that I defined before, and classify and clip it. For this, I'm saying use classify. The classified that I defined is separative emission. For this, I have to put this one here and clip it to my study area. That it's gonna be geometry. Until now it's okay. Right now I can add the classified personalization to my layer. For this, I'm using map add layer, classify it. I can do some further actions by defining minimum. As I said before, it's gonna be 0, the value that we defined. The maximum is gonna be 4 because it's gonna be in 4 classes. And the reason that I'm saying this, as you can see here, very low value is the value 0, and very high class 4. For this, we imported all of this data here. For giving color to our classification, I can use palette and define some preferred colors for your classification. For example, as I said before, for very low class, I'm using blue, green for the low class, yellow for the moderate, red for high, and brown for the very high colonization. Okay, we don't have anything here. Right now I can go here and give it a name. And use map and close the script. Okay, until now it's okay. After defining this part, I can run the code. And as you can see, it successfully run it without any problem. I'm gonna deactivate these parts in order to visualize the result better. This is the classification using separative emission that I did here. We have the same thing for soil index salinity. Okay, very good until now. This is a high salinated area, very high. This one is high, and also this one is moderate. The green one is low, and blue is the very low soil salinity distribution over my study area. For the next step and final step, I'm gonna export my result into my Google Drive. Export image to Drive is a good option for this one. Again, I have to define some parts of this. For example, I'm using image and saying which data I'm interested in exporting. As I said before, I'm interested in exporting machine learning algorithm result. You can do this for the soil salinity index result also from description. I have to give it a name. Soil salinity index, soil salinity 2001. I'm using region to limit the export to my study area, and the escape is 10 meter, as I said before, special resolution. And for the final one, next pixel, very good. Right now it's okay, it's ready for export. Right now I can run the code, and from task we can see it's ready to export. By clicking on run we can export it easily without any problem. Okay, very good. I think we did a good job. If you like these types of video and also the content of this video, please like the video and also subscribe to my channel. Thank you very much for your attention.